Hi everybody. So in this video I want to introduce you to Pythagoras' theorem. And Pythagoras' theorem allows us to find the length in a right angled triangle. And as we get good at this, we can apply it to all kinds of triangles. So in this example, we've been asked to use Pythagoras' theorem to calculate the hypotenuse of each triangle. And the first thing that we need to know is that opposite the right angle will always be the hypotenuse. And this is always the longest length in the triangle. The other two lengths are always shorter than the hypotenuse. So in question B, the hypotenuse is this length because it is opposite this right angle, and the 4 and the 5 will be shorter than this. So for question A, if I just sketch his triangle, and I'm going to draw a square attached to each of the two shorter sides. Now what Pythagoras' theorem states is that the area of each square, so this square will have an area of 36 centimeters squared, and this square will have an area of 64 centimeters squared. Now the area of these two squares have a sum which is equal to the area of a square on the hypotenuse side. So this square will have an area of 36 centimeters squared plus the 64 centimeters squared, which is 100 centimeters squared. Now this allows us to find the length of this hypotenuse, because if the area is 100, then the length would be the square root of 100. And the square root of 100 is 10. So the length of a hypotenuse in this example would be 10. If we look at example B, we begin by drawing a square on the two shorter sides. So this square will have an area of 4 times 4, or 16 centimeters squared. This square will have an area of 5 squared, so 25 centimeters squared. So the area of a square on the side of a hypotenuse will be the 16 centimeters squared plus the 25 centimeters squared, which is a total of 41 centimeters squared. Now we can find this length by taking the square root of this 41. So the square root of 41 gives us approximately 6.4 centimeters. So this would be the length of this hypotenuse, about 6.4 to 1 decimal place. Okay? Let's try another example. Okay, so in this example, we've been asked to use Pythagoras' theorem to find the length of x, which is this length here, for this isosceles triangle. So I told you at the start that we can use Pythagoras' theorem for all kinds of triangles, but we have to create a right angled triangle every time. And by bisecting this angle, we can draw a line from the point to the edge, and this will create a right angled triangle. So our right angle is right here. And we know that this length is exactly the same as this length, which is 12. So now we have our right angled triangle. So if I sketch this out separately, we know the base is 12 centimeters. And to work out the height, well, if this angle has been bisected, then this becomes a perpendicular bisector of this line. So it cuts this line exactly halfway, which means this length will be 5 centimeters. And I'll show the right angle here. So now the hypotenuse is opposite the right angle, which is this length, which means these are the two shorter lengths of a triangle. So I'll draw a square on each of these two sides. We know the area of this square will be 5 squared, or 25 centimeters squared. The area of this square will be 12 squared, or 144 centimeters squared. And these two squares have a sum equal to the square on the side of a hypotenuse. So this will have an area of the 25 centimeters squared plus the 144. So the total area will be 169 centimeters squared. Now we can work out the length of this hypotenuse, or x, by taking the square root of this area, and the square root of 169 is 13. So we know that x will be equal to 13. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe, and you can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again, and take care.